Hello friends, thank you for always choosing Online Maths Expo. Let's do it again today on Circle Theorem. Okay, we do a little review on what we treated last so that it will help us to continue in our today's class. In our last class we have a circle, and if this is a circle, if this is the center of the circle, and this is the arc, the angle this arc made at the center and also made another angle at the circumference. The theorem says that if here is x, this angle will be 2x. That is, angle at the center is 2 times angle at the circumference. You can also have it to be like this. If this is another circle, this is the arc, and this is the radius or the radii. It can also make the same angle again at this circumference. If this circumference is x, this angle is 2x. Okay, that means if here is 30, what you are going to have here will be 60. If this angle is 40, here will be 80. And if here becomes 100, half of what you have at the center is what will be at the circumference. So the circumference, at the circumference, and that will give us 50. You can also have it in this shape. And if this angle is formed here, the angle here, if this angle here is 2m, if angle here is m, here will be 2m. Meaning that if this angle here is 100, the angle here will be 200. And if this angle here is 230, half of what you have here is what we are going to have here, which will give us 115 degrees. That was where we stopped it last time. So in today's class, we are going to complete the remaining aspect of this theorem. And the second theorem says angle in the same segment. I hope you still remember what we meant by segment. This is a circle. A segment is a distance between the chord and the arc. The distance between the arc, this is the arc, and the chord. You can call this the minor segment, and this is the major segment. So when we form, you can also have it this way. So whenever we have angle in the same segment, watch. These angles here are the same. So here is x, and here is x. Meaning that the whole angles in the same segment are always equal. This is the major segment. You can also bring it down. If this angle is also formed here, if the angle is formed down part, and you have another angle formed here, the angle formed here are also equal. So angle in the same segment are always equal. Let's take example, let's take 1 or 2 examples. We have example 1. This is our circle. I hope you are still there with us. This is our circle, and this form angle on the segment. If this angle here is 40 degrees, you may be asked to find this angle x. So what do you think should be angle x? They are in the same segment. They are in the major segment. So anything in the segment are equal. So if here is 40, our x will also be 40 degrees. If I project another segment, this angle here will also be 40. The more I keep projecting, I'll still be having equal angles. If I bring it downwards, supposing I have something like this, and I have another one, if this angle here is 140 degrees, what happens to this angle here, y? Angle y will also be 140 because they are in the same segment, but this one is the minor segment. Okay, let's take another example 2 on this theorem. You can also have something like this. This is our circle, and this is our chord. It forms angle here. You can also have this. This is another shape of it. Provided that in the same segment, if this angle here is 70 degrees, this angle M will also be 70 degrees. Okay, you will pause the video and try these few questions I have for you. Please remember to give me an answer to that. Okay, I know you got the answer correctly. If you did, thumbs up. If you did not, please give us your challenge in the comment section. Please don't forget, we are online on Facebook, Online Maths Expo, YouTube at Online Maths Expo. Please, if what we do interests you, kindly support us by sharing, liking, following, and subscribing to our channel. Okay, we go to the third theorem, which is angle on a semicircle. This is our circle, and you know semi is half of the circle. So if this is half of the circle, this becomes the center. What does the theorem says? That angle on a semicircle, this is a half of the circle, this is half of the circle, so we call it semi. So angle on the semicircle is always 90 degrees. So that means this angle formed here is 90. I can also form it again at this point, provided that form on a semicircle is also 90 degrees. And if I form again, it is also 90 degrees. So angle on a semicircle, angle on half part of the circle is always equal to 90 degrees. I can also bring it down. If I form it this way, this is half of the circle. This is also 90 degrees. I can project it again. All these angles are 90 degrees. Okay, let's look at this example. We are asked to find P. This is our circle. Remember, this means this is the center O. So if this is the center, this is our diameter. So this is the semicircle. And you know that angle on a semicircle is 90 degrees. So what it means is that the total angle here is 90. So if the total angle here is 90, what do you think should be the value of P? So it means that 43 plus P will give us 90 degrees. So our P will now be equal to 90 minus 43. If you subtract 43 from 90, we are going to have 47 degrees. So our P will be 47 degrees. So that when you add the two together, it gives us 90 degrees. Okay, let's look at this example 2. We are told that line BD, this line, and BC are equal. They are equal to each other. So O is the center, and we are asked to find x degrees. This is the angle we are asked to find. Just clearly look at the diagram. You will simply understand that this is also angle on a semicircle. So if it is angle on a semicircle, let's move it to the other side of the board and get it done correctly. Okay, we go together to the board. We have, if you bring out that shape, this is what we have. Remember, angle on a semicircle is 90 degrees. So angle here, the total angle at C is 90 degrees. So what we are having here is 90. But remember, it is not the whole angle at C that we are looking for. We want to get some part of the angles. But there is something special in that question, that these two lines are the same. So if these two lines are the same, if we bring that shape out again, we are going to have something like this. And here is 54. Remember, this has given us a triangle, and there's a special type of triangle we call isosceles triangle, where the two opposite sides are equal. And if the two opposite sides are equal, automatically the base angles are equal. So these are the base angles. And if what we have here is 54, remember that the total angles in a triangle is 180. So we're going to have 180 minus 54 will give us 126 degrees. So if what we have remaining is 126 degrees, to get this value of this angle here, the remaining angle we divide by 2. And if we divide 126 by 2, we are going to have 63 degrees, meaning that this angle here is 63. So if what we have here is 63, just watch, this part of the angle becomes 63 degrees. Can we now get the value of x? Yes, so our value of x will now be equal to 90 because the total angle at C is 90. Remember, it is some part of that C that you already have as 63. So we want to get the remaining part of C. So in that case, it will be 90 minus 63 degrees. And if we subtract 63 from 90, we are going to have 27 degrees. So angle at X is equal to 23 degrees. So that when you add 23 and 63 degrees together, it will give us 90. Okay, you're going to pause the video a little, and try this question I have for you. Okay, if you got that correctly, please try and give us a thumbs up and give yourself a thumbs up. But if you did not, kindly leave your challenge in the comment section. Let's go to Theorem 4. Theorem 4 is you are given a circle, and this circle says that the opposite side of a cyclic quadrilateral are summed to 180. What do you mean by a quadrilateral? A quadrilateral is any four-sided shape like this. So when you have a four-sided shape, this is cyclic. Cyclic is circle, in a circle shape. So when you inscribe a quadrilateral, a four-sided shape, into a circle, such that the vertices of that shape will be touching the circumference of the circle, we call it a cyclic quadrilateral. So the theorem is telling us that if this angle here is A and that angle here is B, that A plus B will give us 180 degrees. And if what we have here is M and here is M plus N will also give us 180 degrees. Let me recall that. The opposite sides of a cyclic quadrilateral sum to 180. Please don't take this theorem to be this. The two of them are not the same. Just watch. This and this are not the same. This is a quadrilateral actually, but it's not a cyclic quadrilateral. For a cyclic quadrilateral, if you watch, the vertices are not all touching the circumference. But in this, the vertices are touching. So whenever the vertices are touching the circumference, it is called a cyclic quadrilateral. Okay, let's look at this example. We are asked to find angle M and angle Y. So for angle M, you know that opposite angle of a cyclic quadrilateral sum to 180. So in that case, M plus 81 is equal to 180 degrees. I hope you are still there with me. So M will give us 180 minus 81. Let's subtract that. 10 here, 10 minus 1 is 9. 17 minus 8 will give us 9. So our M is 99 degrees. So that when you add the two together, it gives us 180. What about our Y? Remember, the opposite sides of a cyclic quadrilateral, if I add this and add this together, it gives me 180. So in that case, Y plus 42 is 180. I hope you are still there with me. Then Y will give us 180 minus 42. If we subtract, 10 here will give us 8. 17 minus 4 will give us 13. So here will give us 138 degrees. So that if you add this and this together, it gives you 180. If you add this and this together, it gives you 180. And you know that for a quadrilateral, the total angles in a four-sided shape is 360. So if these two gives 180 and these two gives 180, the two of them will sum to 360 degrees. Okay, let's quickly look at this example 2. For example 2, we are told that we are given this angle. Remember, this is the center, and we are asked to find angle M, angle P, and angle X. So what do we do? If we are getting angle P, let's first of all get angle P. So for our P, remember this has formed angle at a point, and angle at a point, like I told you, is equal to 360. So our P will be 360 minus 213 degrees. So let's subtract. 10 minus 3 will give us 7. 5 minus 1 will give us 4. And 3 minus 2 will give us 1. So here P, angle P will give us 147 degrees. Then we can get angle M. Angle M, remember the first theorem we treated that angle at center, Whatever you have at the 2 times of what you have at the center, of what you have at the circumference is what you have at the center. So in that case, this angle P will be equal to 2 of what we have at the circumference. And what do we have as P? Our P is 147 is equal to 2m. So we divide both sides by 2, and that will give us m. 2 will divide itself, divides 14 is 7, and divides 7 is 3. So we're going to have 73.5 degrees. Okay, you are going to pause the video and try the question I have for you. Okay, I hope you got that answer correctly. If you did, still give yourself another thumbs up. If you did not, please let's know your challenge in the comment section. Let's look at another theorem, that's theorem 5, and it says the exterior angle, this is an extension of theorem 4. Remember, this is a cyclic quadrilateral. So if I happen to extend this chord to form an exterior angle here, that this exterior angle here is equal to the opposite interior. I take that again. It's an extension of theorem 4. This is a cyclic quadrilateral, and if I happen to extend any part of the chord of that quadrilateral, if I extend this chord, the angle I form at the exterior is equal to the opposite interior. So this is the opposite. Watch. These are opposites. So whatever I have here will be equal to what I have here. If I extend this one too, remember it is the chord that I am extending. So if I extend this one too, whatever angle I have here will be equal to whatever I have in the opposite. So this angle is P. Here will also be P degrees. That is for that theorem. Okay, let's look at this example. I hope you are still there with me. Okay, for this example, we are asked to find exact value of x and value of y. So if we are looking for the value of x, what do you think should be the value of x? It's just very simple. Our x, remember, the opposite is equal to the exterior is equal to the opposite interior. So if you look at this, the two ones that are opposite are this. So whatever you have here should be what you have here. So in that case, our x is equal to 92 degrees because the exterior angle is equal to the opposite interior. Okay, then if we are looking for the value of y, it's still very simple. Remember, this has formed a straight line. It has formed a straight line when we have here to be x and here is y. And you know that this our x is already 92 degrees. So can we get our y? Our y will now be equal to, remember, sum of angles on a straight line is equal to 180. So you have 180 minus 92. When you subtract 180 and 92, we are going to have 78 degrees. And sorry, if you subtract 180 and 92, we are going to have 88 degrees. And that is the value of y. So that when you add 88 and 92 degrees together, it will still give us 180. So here is 88 degrees, and here is also 92 degrees. And remember, you can also do it this way, that the sum of two opposite angles of a cyclic quadrilateral will also sum to give you 180, whichever way you want to do it. Okay, just pause the video a little and also attempt to the question I have for you. Please remember, if what we do interests you, kindly follow us on Facebook at Online Math Expo. Then if you're on YouTube, subscribe to our channel on Online Math Expo to support what we do. Thank you. Till meet another time. Bye-bye.